morning dear students, welcome back to our class. I hope you are going through the videos and clearing your concept. If not so, please do it and please utilize your time. Now, begin ahead with a quick recap. We have done the introductory part of refraction. We understood the principle of reversibility and utilized it in many derivations along with different intervals, right? We understood how your ray of light is refracted through a glass slab having thickness T, which is leading to the concept of lateral displacement. Lateral displacement is actually the perpendicular distance between your incident ray and the emergent ray. We also derived an equation for this x, which is equivalent to T if your I is equivalent to 90 degree. What does it mean? It concludes us that your parallel shift cannot exceed the thickness of the glass slab. Yes. So please go through the videos and clear your concept and come to this video. Here we will start with the further part, application of this refraction. Now, have you ever wondered how the surface of water tank appears to be shallower, or why it happens when you keep any object inside a water bucket, like during this crisis of corona, you are generally washing your fruits or vegetables, keeping it in bucket. So have you observed that fruits or vegetables are appearing to be raised up from their original position? If not, so after my video lecture, you have to do it. You have to make yourself sure. So whatever we are studying, whatever we have derived here, it is practical, right? Physics is everywhere and it has to be practical. So I will first explain you the theory and the derivation for this. Just pay attention. It can be explained with the help of real depth and apparent depth. Okay, so begin first. I have considered here a water tank which is filled with a beaker which is filled with water, right? So this behaves like a denser medium. It is actually a denser medium, and the reason above it is a rarer medium in the form of air. I have considered an object O inside the water and at the bottom. If a ray OA is an incident ray striking to the surface at point A and another incident ray OB is striking to the surface at point B. If we draw a normal to this point B and to this point A, we can clearly observe that your incident ray OA is refracted along AD and your incident ray OB striking to the normal, making an angle of incidence I in the denser medium. And now this incident ray OB is traveling from denser medium to rarer medium. It bends away from the normal along BC, making an angle of refraction. Now, both the refracted ray are actually appears to diverge from a point I, and therefore as the line is drawn straight back, therefore it lie on the same line. We can write it down. It is also angle of refraction at point I, and of course your incident ray OA is normal to the surface, therefore we can draw here a perpendicular, right? Now with the help of Snell's law, we can obtain the relation for this. What does your Snell's law says? Snell's law says the refractive index of air with respect to water is equivalent to sine of I upon sine of R. What is your angle of incidence? Your angle of incidence is at point I, as your DO and normal drawn at point B are parallel line. Therefore, by this alternate angle, it is also your angle of incidence I at point O. Now, therefore, your sine I becomes sine of angle of AOB. AOB. And your refraction angle is at point I. Therefore, sine of AIB. So, how can we write this sine trigonometry formula? We can equate it in terms of trigonometric ratio for sine can be written as sine of AOB means opposite, which is AOB opposite AB, upon hypotenuse, that is BO, divided by sine of AIB. Again, for this opposite is your AB and it is divided by hypotenuse, which is BI. Now, this is nothing but refractive index of air with respect to water. As we know that the pupil of our eye is very small and the refracted ray enter our eyes only if your point B is very close to point A. So therefore, due to small size of pupil of our eye, we can write this BO is equivalent to, nearly equivalent to AO, and this BI is nearly equivalent to AI. So therefore, refractive index for air with respect to water can be written as in terms of AI upon AO, right? How I have written this? It can be the ratio of AB upon AO multiplied by AI upon AB. AB will be cancelled out, means AI upon AO. Now, if I have written the refractive index of water with respect to air, I have interchanged it. It is possible with the help of principle of reversibility, means it can be written as 1 upon refractive index of air with respect to water. And if I have inverted this concept, so obviously the remaining side is also inverted, or we can take reciprocal of it. It becomes AO upon AI. If suppose this term is written as refractive index of water upon refractive index of air, means we get AO upon AI. If your refractive index for water is mu and refractive index for water is 1, so we get this relation. Mu means refractive index is the ratio of real depth upon apparent depth. Means we can say that your apparent depth AI is equivalent to real depth AO upon mu. Okay, so this relation, which can be understood from the diagram, your apparent depth, which is AI, is small as compared to real depth AO, right? Because of this relation. As refractive index of many other surfaces, many other material except vacuum, okay? So, it is always greater than unity. Refractive index of any medium except vacuum is greater than unity, and therefore your apparent depth is greater than real depth. Okay, so now we have to understood what the uplifted position is called to be, right? As you can see, your object is at point O, but it is supposed to be, or it is uplifted from its original position and appears at point I. So this raised in the position in denser medium, obviously, of course, related to object only, right? So the raised in the position in denser medium is called as normal shift, and it depends upon your real depth and normal depth. How? This normal shift denoted by small d depends upon your normal shift this is your normal shift. So it is equivalent to real depth minus apparent depth. Okay. So real depth minus apparent depth. So what we have, real depth equals to, real depth is AO, denoted by AO. And what is apparent depth? AI. Right now I have proved it. This is nothing but your apparent depth. Okay. So this apparent depth is equivalent to real depth upon refractive index. So if I took this common AO, in bracket we remaining with 1 upon 1 minus mu. Right? Means your normal shift D. What is normal shift denoted by D? It is a uplifted in denser medium called as normal shift. So this D is equivalent to AO. AO is real depth. This real depth is equivalent to small t, means the thickness of your refracting medium. So thereby this normal shift D depends upon t in bracket 1 minus 1 upon mu, means it implies, this equation implies normal shift is depends upon thickness of the refracting material and depends upon the refractive index of the medium. Greater the value of refractive index, greater will be the normal shift, greater will be the uplifting in the position. So here we understood the real depth and apparent depth, and now you will do the experiment to confirm this, whether it is true or it is wrong, right? Now, continued with this, we can prove how your atmospheric refraction is very useful for us, or how it affects the length of the day. Yes, this atmospheric refraction affects the length of our day. How? See, starting from Earth, okay, I have considered origin Earth, obviously. Then we can say, with reference to the Earth, with reference to the ground, your height is increasing, and at certain height, your sun is placed. Okay, so with altitude means with height, your density and refractive index decreases. Means the density of the atmosphere near the Earth is greater as compared to the atmosphere going towards the sun. Means any ray which is coming from sun is traveling from every time layer by layer, rarer to denser layers of air. Okay, means any ray coming from sun is traveling from rarer to denser medium, and every time it will bend towards the normal. So what happens because of this? So because of this, the ray coming from sun is traveling in a curvical path and reaching to the observer's eyes. But observer always find an object in a rectilinear path of the light incident on his eyes. So according to that, he will backtrace in a rectilinear path that rays and assume that your object like sun is placed over there, and thereby it makes us the sense, or it makes us the visible sun even before sunrise, and it makes us the sun is visible even after the sunset. I can explain you this with the help of diagram. Just pay attention. I have drawn this as a horizon. What horizon? and your earth is here. This is the earth. Okay. So your observer is standing at this position. Observer. Okay. This is the earth and observer is standing at this position. What happens? Suppose the sun is here. This is the actual position of sun. And just now I told you it will near the sun. It's more denser, right? And then layer by layer its density and thereby its refractive index is decreases. Now the ray coming from sun, right? It will coming from sun and get diverting at each stage, right? How? As it is traveling from rarer medium to denser medium, it will bend towards the normal. It is traveling from rarer medium to denser medium, means it will bend towards the normal, and thereby it will reach to the eye of an observer in a curvical path. But what happens? This observer is considered or understood this ray is following a rectilinear path. This observer understood that this ray is traveling in a rectilinear path, and thereby by backtracing he assumed that the sun is at a position S dash, which is the apparent position. Your actual position is S. This is the real position. And this is the apparent position. Okay. So, by this, there is a shift of 0.5 degree. Your sun is shifted by 0.5 degree, which lead to the term of 2 minutes. And therefore, your sun becomes visible even before sunrise and even after the sunset for 2 minutes. And therefore, in total, it affected our length of the day by 4 minutes. It is very important that your happiest day you are enjoying by 4 minutes. If suppose this atmosphere would not be present here, then your day will be decreased by 4 minutes, right? Because of atmosphere, the refraction is there, means due to atmospheric refraction, you are enjoying it by 4 minutes, right? And now, again you can explain by yourself why the sun appeared to be flattened or oval shaped. The same phenomenon with attitude, the density, and thereby your refractive index decreases. Now, the light coming from the top and bottom of the sun will be shifted by different degrees at the horizontal plane, and thereby it appears to be flattened at the horizon. But if you saw it from sides, if sun is visible from sides at noon time, then we can say that there is a same amount of refraction or shifting in both the rays coming from sides, and thereby it will appear circular only, right? So even there are many examples which depends only on the atmospheric refraction, the twinkling of the stars, or as right now I have explained you why the sun is appears even before sunrise and after sunset. Even I have explained you why it is flattened in shape, right? So it is a very interesting concept and beauty of physics to see it everywhere around us only. So in this video we have done up to this only, and now next we will continue with the total internal reflection and then with the optical fiber. Okay, so thank you.